China unveils the Fujian, its largest aircraft carrier yet, sending a clear signal. Beijing wants to join the world's premier maritime club. Headlines ripple across defense newsrooms. Is U.S. naval supremacy under threat? When the Fujian slid into the water, it sent waves across the Pacific and into Pentagon briefings. Can a new carrier really shift the balance of power? Or is U.S. experience too deep to overcome? Let's start with the basics. A floating airbase is any ship that can launch and recover aircraft, projecting power far from home. The classic example is the aircraft carrier. It's a massive vessel, bristling with planes and crew. But other types exist, each designed for specific missions. First, there's the pure aircraft carrier. This is the big one, the centerpiece of naval aviation. Then come amphibious assault ships. They look like smaller carriers and can launch helicopters, tilt rotors, and even some jets. Expeditionary sea bases, or ESBs, are another type. They're floating logistics and mission platforms, supporting helicopters and special operations. Finally, hybrids blur the lines, mixing features to meet complex needs. Each design has its strengths. Carriers carry the most planes and have the longest reach. Amphibious ships excel at launching troops and gear ashore. ESBs keep operations moving in remote waters. Hybrids are flexible, able to switch roles as threats change. The diversity of floating air bases lets navies adapt, choosing the right tool for the mission, not just relying on one big ship. Launching a fighter jet off a moving ship isn't easy. Two main systems make it possible: CATOBAR and STOBAR. CATOBAR stands for Catapult-Assisted Takeoff but Arrested Recovery. Basically, a steam or electromagnetic catapult slings planes off the deck, while cables catch them when they land. It's high-tech, efficient, and allows heavy, well-armed aircraft to launch with full fuel. STOBAR means short takeoff but arrested recovery. Here, planes use a ski jump ramp to leap into the air. Recovery still uses arrestor wires, but takeoff is powered by the aircraft's own engines plus the ramp's angle. It's simpler and cheaper, but limits the weight and size of the planes launched. CATOBAR is the gold standard for heavy modern carriers. Most U.S. carriers use this system. STOBAR is easier to build but less capable, used by older Russian and Chinese ships. The choice affects everything: aircraft types, mission flexibility, and operational tempo. For China, shifting from STOBAR to CATOBAR is a leap toward parity with the world's top navies. The United States Navy operates 11 nuclear-powered aircraft carriers. This isn't just a number, it's a strategy. These ships aren't meant to defend the U.S. coastline. They're designed to project power anywhere on the globe at a moment's notice. American carriers are always moving. They patrol the Pacific, Indian Ocean, Mediterranean, and beyond. The doctrine: deterrence through presence. When a crisis erupts, a carrier strike group can arrive fast, armed with dozens of jets and missiles. No other country maintains this worldwide tempo. Nuclear propulsion is key. These ships can sail for decades without refueling. They carry enough supplies for months at sea, supported by a web of logistics ships. The result? U.S. carriers are always ready, always near hotspots, always a step ahead. This doctrine shapes everything, from ship design to crew training and global politics. Enter the Ford-class carrier. This is honestly the latest and most advanced ship in the U.S. fleet. Its biggest headline? The Electromagnetic Aircraft Launch System, or EMALS. Instead of heavy steam catapults, EMALS uses electromagnetic rails to hurl jets into the sky. It's smoother, faster, and less damaging to planes. EMALS also boosts sortie rates. That means more planes can launch and land per day. Ford-class carriers can theoretically generate 25% more sorties than older Nimitz-class ships. The new design also introduces advanced arresting gear, improved elevators for moving munitions, and better automation to reduce crew size. But, these breakthroughs come with teething problems. New tech is tricky at sea. Early Ford-class deployments faced delays, but the payoff is a ship that can do more with less, ready for the demands of modern warfare. The Ford class sets a new standard, one China and others are racing to match. An aircraft carrier never sails alone. It's the core of a carrier strike group, a floating city, airport and fortress, all in one. Surrounding the carrier are guided missile cruisers and destroyers. These ships provide air defense, hunt submarines, and launch their own strikes. Fast attack submarines lurk below, ready to hunt enemy ships or protect the group. The carrier's air wing is a mix of fighters, electronic warfare jets, helicopters, and surveillance planes. The FA-18 Super Hornet is the workhorse, backed by the E-2 Hawkeye for radar coverage and EA-18G Growler for jamming threats. Helicopters handle search and rescue, anti-submarine, and logistics missions. Supply ships, oilers, ammo carriers, and stores vessels shadow the group, keeping everyone fueled and armed. This complex dance allows weeks of operations without needing to visit port. The whole package is designed to survive, strike, and support itself, anywhere, anytime. China's carrier journey began with the Liaoning, a retrofitted Soviet ship mainly used for training. Then came the Shandong, a homegrown carrier with some improvements. But the real leap is the Fujian, launched in 2022. China's first Kato-bar carrier. It's larger, more modern, and uses electromagnetic catapults like the Ford class. Fujian marks a major step in China's quest for blue water naval power. Aircraft carriers aren't China's only bet. The plan, or People's Liberation Army Navy, is rolling out these Type 075 amphibious assault ships. These are big, flat-topped vessels able to launch helicopters, drones, and even amphibious vehicles. They're really built for landing troops on beaches, which is key for so-called island seizure missions in the South China Sea, or, honestly, against Taiwan. There are also rumors about a Type 076, a larger hybrid ship that might use electromagnetic catapults for drones and short takeoff aircraft. If that actually gets built, it would kind of blur the line between a carrier and an assault ship. China's goal here is pretty clear: a flexible fleet able to adapt as technology and threats change. This whole multi-platform approach actually mirrors U.S. doctrine. The U.S. pairs supercarriers with amphibious ships and ESBs for maximum flexibility. China wants the same range of options, but well, it's still early days. Integrating these platforms takes time, especially under combat pressure. Each new ship expands China's reach, but also demands more logistics and skilled crews. Cutting-edge launch systems get the headlines, but real carrier power is below deck. Nuclear power lets U.S. carriers go for decades without refueling. Conventional carriers, like the Fujian, need fuel every few weeks, tying them to supply ships. EMALS catapults need massive power. Nuclear reactors provide it. But sortie rate depends on hangar flow and how fast crews move jets. Logistics is the real Achilles heel. Everything must arrive by sea. Is China's new carrier fleet a real threat? Or just hype? The answer is complicated. The Fujian is a technological leap, but matching the U.S. Navy takes more than steel and catapults. Nuclear power gives the U.S. unmatched range and endurance. Decades of training and global logistics give the U.S. a hard-to-match edge. In the end, it's not hardware, but readiness and adaptation that decide who rules the waves.